At a high level, biostatistics is a way of thinking about the world and processing information. At a practical level, it's a set of skills and tools that enable us to extract information from data to answer important scientific questions, and in particular, health-related scientific questions.
Biostatistics encompasses all things related to the analysis of biological and health-related data. This can range from designing and analyzing clinical trials for drugs and vaccines, to analyzing genetics data to determine how one's genome is associated with risk of adverse health outcomes, to looking at how exposure to pollutants can affect community health.
Biostatistics is a discipline that engages with and uses data to answer questions in biomedical sciences and in public health. And in particular, it differs from other fields that also engage with those questions because it's primarily about working with data, manipulating data, and understanding questions from the data.
Before I became interested in biostatistics, I was first interested in the field of public health.
I was originally interested in mathematics and was interested in programming. I liked building things.
But as I started learning more about public health interventions, I kept asking myself, how do we know that this really works? And then when I learned about epidemiological methods that were used to figure out why it worked, I'd ask, how do we know that these methods are accurate? How can we improve on this method?
And I went to graduate school and in a statistics program, but engaging primarily in biostatistics research, looking at genomics, looking at predictive modeling, trying to understand how to take what are called high-dimensional or collections of many, many measurements on people and use that to learn about their underlying biology.
And now I realize that it's not just public health that relies on biostatistics, but it's all medical interventions. And the methods from biostatistics extend to every area of scientific inquiry, from macro-level questions of society and economics to micro-level questions of human biology. It's an incredibly exciting field.
I do lots of different things. I wear lots of different hats. I work with a group in cystic fibrosis research, and I help them design and analyze clinical trials, trying to understand effective interventions for patients with cystic fibrosis.
I chose UW because of the people and the environment.
I think University of Washington is a great place to attend. The coursework is very rigorous and prepares students well for a wide array of opportunities.
I chose to be a faculty member at UW because it is a fantastic institution engaging in awesome research. I think it really believes in supporting students, in mentoring students, which is something that I strongly believe in as well.
There's also a ton of public health and biomedical research going on internally at the University of Washington. So there's always exciting problems to work on and investigators to collaborate with. We're excited to have students working with them.
Not only are the faculty members and other graduate students fantastic people, but the opportunities that the department affords students, being situated in a city with enormous growth both in medicine and public health as well as technology, are unparalleled in my opinion. After graduation, I hope to continue conducting research in an academic institution.
I'm not entirely sure since there are so many options, but really I've enjoyed research, so I'm currently leaning toward a career either at a research institute or at a research-focused university.
Right now, there's a huge demand for people with biostatistical training in the tech industry, particularly in Seattle. I know biostatisticians that have gone on to work as statisticians and data scientists in companies like Google, Microsoft, Amazon, and Facebook.
And some folks have also branched out and worked at not-for-profit organizations like the Gates Foundation. And also a lot of students go off and pursue traditional academia, either taking a position at a teaching college or at a traditional, more research-focused university.
Really, the tools that we teach around predictive modeling, statistical inference, study design are just useful really across the board.
The skills that biostatistics degrees equip you with, including strong analytical thinking skills, statistical modeling, and programming, are in very high demand right now.